All right, this video is going to walk through the first two problems on our practice correlation and linear functions homework. Uh, and so let's just dive right into number one. So we have Tony going on a run. When he first looks at his watch, 6 minutes have passed and he's run 3/4 of a mile. And then he checks his watch 24 minutes later. So that word later is implying 24 minutes have passed between the first 6 minutes and this. So the reality is he's actually 30 minutes into his run. Just, thinking about that in my head. And he's run a total of 3 miles. Now, generally in this situation, as the time spent running increases, the distance that Tony has run is also increasing. There's a general positive trend between these two relationships. As time goes up, so does the distance. Now the question is sort of by how much. So we can look at a few things. So one, I just want to know what's the absolute change in the distance he ran during this sort of period that we're looking at. So between the 6 minute mark and then the 24 minutes later. So, well, he ended at a total distance of 3 miles, and he started at 0.74 or 3/4 of a mile. So if I subtract my newer value minus my old value, I find that he ran 2.25 miles in those 24 minutes. So then the question is, well, how long did it take Tony to run 1 minute? So the reality is I want to, you take, his change in distance, and I want to divide that by his change in time. How much time went by. So, and that's going to get me the distance per single minute. So we said on part B that he had run 2 miles, 2.25 miles. And we said that, 24 minutes passed because, it was 24 minutes later after he first checked his watch. And so 2.25 divided by 24 comes out to about 0.09, and there's a whole decimal here. I'm going to write it down. You don't need to. You could have rounded. And that's miles per minute. So each minute that goes by, he runs that many miles. Now, if he continued to run at this pace, how far would he run in 40 minutes? And this is just sort of a generic sort of separate situation. There's no well, if he started, at this distance, nope, it's just how far would he run in 40 minutes? Well, if he runs this distance up here every minute and 40 minutes go by, this is a sort of multiplication relationship. So here's the distance he runs each minute. So, per 1 minute. And we have 40 copies of that because that's going to happen 40 times. And it turns out he'll run about 3.75 miles in 40 minutes. All right, the next one. If he continued to run at this pace, how long would it take him to run 5 miles? There's a few different ways we could interpret this. One, with the word continued there, maybe I'm thinking, okay, he's already gone 3 miles, so how much would it, how long will it take him to run the additional two, and so forth. I'm going to treat it as just in general, how long did it take to run 5 miles? But again, the wording on this, and I wrote the problem, but my own wording is a little vague. Uses some room for improvement. So I'm going to approach this two different ways. So one way is I can use proportional reasoning because we're sort of going off this idea that he has this sort of fixed distance that it takes a certain amount of time. And up on part C, we said, well, he could run 2.25 miles in 24 minutes. So I'm going to actually do this as a minute in mile relationship. So I know that it takes 24 minutes for him to run 2.25 miles. Well, that relationship should stay the same when he runs 5 miles, but I want to know how much time will it take. So I'm sort of going back to this notion of proportional reasoning that we set up way long ago, back opening weeks of the semester. Now, keep in mind, there's all different ways to solve a proportion. I find the quickest way I'm just going to multiply by 5. I sort of treat it as two fractions, just a sort of generic equation. So I'm going to multiply both sides by 5, and I'm going to figure out my time here. So 24.25 times 5 comes out to about 53.33 minutes. Now, 100% acceptable, totally works. You can do it this way. It gets me the answer. The other way is to sort of go off of our linear functions that we are just dealing with. And so we're making the assumption, the distance he runs would be equal to sort of this miles per minute times the number of minutes he runs for. That's what we sort of reasoned in part D here. So I have that 0.09375 times the number of minutes he runs for, and that's going to find me how far he ran. Well, if I know he ran 5 miles, so I'm sort of setting up an equation here, I could solve for the number of minutes he ran by dividing by that rate. And I would end up with, believe it or not, the exact same answer that I got going proportional reasoning way. Minutes came out to 53.33 minutes. And so that's just sort of a different way to think about it. If that sort of clicks in your brain, I highly recommend it. Proportional reasoning also works in this case. So, it's a little bit of like, what makes the most sense to you? Should be a strategy that you work with. All right, the next problem, we are given this really interesting data display about Dick's Sporting Goods and their net annual sales over the last 24 years. And so we are asked to find the absolute change between 1999 and 2023. Well, in 1999, the store was making 0.73 billion. And in 2003, the store was making 13 billion. So 13 billion minus 0.73 comes out to an absolute change of $12.27 billion in sales. Now, and that's sales each year. So over the course, that's how much their profits have, not profits, their net sales have grown. Now, if I wanted to know, if I were to, almost where that dotted line is, draw a line here, what would be the yearly growth approximately each year? So if I take that absolute change, and then I'm going to divide it by the number of years that have gone by, and this is 24 years, and I would find out that each year the net sales is growing about $0.51 billion. And that's a per year. Each year the sales increase that much. Now, I want to make a prediction about where it's going to be in 2027. Well, first off, how many years has gone by? So this is 4 years since the 23 date on this graph. And so if I take that rate that we found up top and I say, okay, well, it's growing, $500 million each year, and we have 4 years that go by. So 4 times 0.51 gets me that, my sales have grown about $2 billion over the course of those 4 years. But, so this is my increase in 4 years. But keep in mind, in this case, unlike the running problem, we didn't actually start at $0. So it's not like they only make $2 billion. In the year 23, they are already at $13 billion. So we're starting at 13. We have an initial value here, and we're adding that 2.04 because it's growing that much to get you that we would expect, we predict the net gross sales or the net sales for Dick's Sporting Goods in 4 years will be probably around $15.04 billion. If it keeps growing the same way that it was growing. Now, this is a prediction. Might not happen, might happen. You can't know 100% certain until the date actually passes. We're just making some guesses. Hopefully this sort of helps you on these first two problems. On the back side, we're going to turn our focus a little more to scatter plots and correlation and how we make these same types of predictions when we have a lot more data points.